Okay, hi everyone. We're here to talk to some people from Moon who've built the Glow programming language, which is one of the languages that runs on the Cardano blockchain. I'm Simon Thompson from IO. I'm here to talk to Francois-Rene and Alexander. Would you like to introduce yourselves?
I am Francois-Rene Rideau. I am a computer scientist working in programming languages and distributed systems and cryptocurrencies. And uh, I've been working in the field of cryptocurrencies for 3 years, like seriously. And now for the last 2 years, we've been building this programming language Glow that I think will change a lot of things about uh, the how people write DApps. And my partner here is, well,
Well, I'll take it from there. I'm Alexander Smart. I am the Chief Operating Officer of Moon, and I'm a lawyer by training. I am not you would necessarily think at first glance that the right person, but what law does and teaches you is how to get parties who have every reason to not trust each other to cooperate, and that's a key feature of Glow, and it's a key part of Glow's mentality as we approach the blockchain. And so that's how a lawyer fits here. And Faria and I have been working together for about 2 years now, and we think things are going pretty well.
Excellent. Okay. Well, let's start off by me asking a question. What is Glow? Can you describe briefly what the language is?
I would say the one sentence is Glow is a language for decentralized applications. But what that means will take more explanations. Alex, maybe you can complement that.
Yeah, so Glow is a language for decentralized applications, and it's especially a language that's designed for portable decentralized applications. That means if you want the option to run on more than one blockchain, that is really what Glow is designed for, is the key functionality in the back. In addition to that, we believe in simplicity, and that's part of what we think portability gives, is this simplifying the process of building your DApp one place and having it run multiple places. And go along with that, we want our language to be simple and familiar enough without being deceptively familiar in ways that lead you to bad mistakes.
Okay, that's great. So just to clarify one thing, when you say it's portable, does that mean you can run on multiple blockchains separately, or is it a language for writing applications which run on a number of blockchains simultaneously? So a multiple blockchain app. Which of those two is it?
I'll take this one. For now, it is separately because to work together, you need some kind of bridge technology. And we have plans to implement a lot of bridge technology that does not exist yet. We plan also to implement what bridge technology does exist already, but these are slightly different things, and we believe one leads to the other naturally. So we want first to, and we already have the language that runs on multiple platforms, and we want to add more platforms, but we also want to add eventually all this bridging support. But that's not today. That's on the roadmap.
Okay, perfect. Thank you. So I know Alexander said you don't want it to resemble things too much, but could you say, does it resemble any language that listeners might be familiar with? Is it like, I don't know, APL, or is it like C++? Is it like anything people would know?
Yeah, it's like JavaScript is essentially what we're trying to create. It's a dialect of JavaScript, but that warns you if you're deviating, if you're getting away from what you might think of as JavaScript.
Okay, that's very clear. And there's a big community of JavaScript developers out there who you'd be trying to target with this.
Yes, I think that the idea is that we want to look like JavaScript. At some point, we have to be different from JavaScript because we have to target specific to the blockchain. And when we are different from JavaScript, we try to introduce things like types, like being pure or mostly pure, pure functional. We do have some side effects that are blockchain specific, but we want the core language to be mostly pure. And in a way, we can resemble things like TypeScript or Rescript if you're familiar with these type JavaScript extensions. But we do have blockchain specific elements, and when we do, we want them to not look like JavaScript. We want to say, oh, this is not something like, oh, it looks like a JavaScript program that would do this. No, it looks like something. If we're doing something different, it will look different. And that, to us, it's a feature. Both the familiarity where the things are the same and the non-familiarity where the things are different are both important.
Okay. Yep, that makes perfect sense. If we dig down a bit more technically, is a language Turing complete? I mean, within a blockchain context, or does it have limited resources in any way?
I'll take this one because it's technical. It's quite technical. First, I would like to say that whenever I hear the word Turing complete, boom, boom, boom. It's a big alarm because the term is often misunderstood or abused to the point where it brings more confusion than enlightenment. And to me, the important concept that is in Turing's paper is the concept of universality. That means that within a domain, for Turing, the domain was partially computable functions from natural integers to natural integers. But for us, the domain we're interested in is decentralized applications. So within a domain, a language might be universal. That means that it covers the domain so well that all the other languages in the domain are a subset of it, modulo some simple transformation. And that's what we're aiming for. We're aiming for our language Glow to be universal, but to be universal in a specific domain, which is the specific domain of decentralized applications. And I admit I don't know exactly what decentralized application is or isn't, but we're not trying to be universal for hopefully bigger domain that is partial computable functions, but we are trying to be universal for decentralized applications. Then the question is, what is a DApp? Yes, and I have a semi-formal answer. It's not formal enough maybe for a mathematician, but I think it's formal enough for most people. To me, a DApp is an interaction between multiple distrusting parties who are exchanging assets on a public ledger, and it's an interaction that is subject to algorithmically verifiable rules. So there are the 4 point interactions. There are these people who exchange message do multiple things at the same time. There's a concurrent setting, inherently concurrent setting. There is this inherently adversarial setting. You have people who you don't trust. If you trusted each other, you would not need a blockchain program. You just do the thing. You would not need anything like that. And you are exchanging assets. You have to be on a public ledger, otherwise it's not a DApp. And the rules must be algorithmically verifiable. That means a computer can verify them, not just any computer. The computer at the center of this consensus, a blockchain, Plutus or Ethereum or whatever it is, must be able to verify that. So that's a DApp. And we want to be able to write any interesting DApp.
And I guess a crucial thing here that people might want to hear a bit more about is what features you add. You talk about the adversarial setting. What is it how do you address that particular aspect of the application area in your language?
Yeah, so I mean, the first piece of what we're doing is you have to have the mindset and the approach to think through the fact the parties here don't trust each other. And yet, you have to get focused on creating incentives to enable them to trust within this narrow confines. There's not general trust here, but there can be narrowly defined trust for aligned incentives. And that's the underpinning logic of what we are doing. And there's a number of ways that we build that out. And I'll let Francois get into more of the technical part of like what that outside logic looks like when you build it into code.
Alignment of interest. In a way, most logics that exist assume that all the parts of a program conspire together toward a common goal. It's an assumption at the beginning of all your proofs in all the existing logics with which you prove software correct today. But that's exactly what you cannot assume for a decentralized application. For a decentralized application, this must be not a hypothesis, an input to your logical specification. This should be an output. This is one of the requirements. This is one of the things that, of all the programs, our program happens to align the interests of the participants within some other hypothesis. But this is this is not an input of your logical spec. Should be an output or required output of your logical spec. That makes decentralized applications totally different from a logical point of view from all other applications. That means that no existing logical framework that exists together today is fit as is to prove the correctness of decentralized applications. And that's one of the things we're working on.
So just one last question in this space. So does that mean that you have extra features in the language, or does it mean that you restrict features? I mean, I can see you could achieve those results in two ways. Maybe you do both.
Yes. So extra features, the most important extra features, of course, is a built-in notion of participants. Very much like in Marlowe, for instance, you have but participants is not something you can reconstruct on top of a low-level language, as you have in Solidity, for instance. You could not have any useful logic in this way, or it would be much harder to reconstruct the logic this way. Participants, the notion of participants is like built deep into the language and into the logic specifications of what's happening. Restrictions, yes. The current language, so to go back to your question, the current language does not even have recursion, and there again it's like Marlowe. But we are working on adding recursion right now with many restrictions on what you can do with recursion. But we do intend to have recursion in the end, and soon actually. Perfect.
So just one last tiny question about the language itself. Are you based on an account model or a UTXO model, or are you model agnostic in that sense?
I'll take this one also. So GLOW is supposed to work on both account and UTXO blockchains. So we don't care, or well, we care in some ways as implementers, which is which, but as a user of GLOW, you don't have to care which is underlying blockchain. We abstract these things away from you. And some aspects of GLOW assume some kind of account. You have a notion of identity. You deal with someone else with an identity. You create an interaction. So there is some notion of identity. And at the same time, we understand that especially if we want to support UTXO blockchains that are more primitive in some ways, in both good and bad sense, than account blockchains, we have to have a data model that is more UTXO-like. So when we have recursive data structures, etc., we prefer to express them in a more UTXO style that is pure linear, if you want a programming language view of it. So UTXO is a purely linear view. Account is a mutable imperative view. And in a way, the two are equivalent, but in other ways, sometimes you really want one or the other. And in GLOW, we're trying to offer whichever makes more sense, whichever is nicer for you. And then the language will translate it to accounts or to UTXOs underneath.
Okay, that's a very good point. So I think we've got a very clear picture about what the language is, and I think we've also begun to answer the question about how it fits alongside Marlowe and Plutus and so on, which are also on Cardano. But we'll come back to that a bit later on. Let's talk a bit about how GLOW is implemented on Cardano. Can you give us the big picture there?
Okay. So we support right now. We only support very well the EVM backend, and we run on the Cardano EVM DevNet right now. But we also have a Plutus backend, which is right now experimental. We have a working proof of concept, but it does not support the whole language the way we want. And we are hoping to make it into an alpha quality release that can actually run in your testnets, or if you're very daring in production, by the end of the year. But we are hoping to make something that actually runs in production and is robust and solid and with a quality we are proud of, hopefully by the first half of next year, depending on, once again, which features you need or don't need in your particular program. But by the first half of next year, we'll have something that really runs well on Plutus.
Okay, I mean, because the way Marlowe runs on Plutus is that we have an effectively on-chain an interpreter runs, and so the particular Marlowe script becomes a datum that is passed from transaction to transaction. Are you taking a similar approach, or are you more compiling the
we've been studying our options, and right now we agree with Marlo that that's only option that is feasible with finite resources or affordable resources to have an interpreter for our language in the Plutus application backend. We believe that in the long run we can do better, but that will require much more resources and probably will require a few tweaks to the Plutus core. I think there are already a few features we've discussed. Hey, do you have this feature or not? They don't have it yet, and maybe we can convince them to add those features that would make our life much easier. Do things like what they call that in Bitcoin MAST, Merkleized code, and there are plenty of tricks we could use to compile efficiently to Plutus if Plutus had these neat tiny things.
Great. Okay. No, that's really helpful. And I suppose that perhaps answers with one of the questions I was going to ask, which is, what have been the major technical challenges you've had to overcome in implementing Glow on Cardano?
I have several remarks, but I suppose the first part is that Cardano runs with Haskell, and Haskell is not for everyone. It requires a specific kind of intelligence to be good with Haskell. And I'm not sure I have it. Happily, there are a lot of people in the world who have it, and you can hire. But definitely, we have to hire the right people. Then there are things like you must generate NFTs just to identify which UTXO corresponds to which state of the interaction. So that's an additional challenge. And there are always size limitations, virtual machine limitations. Once again, we already have a few extensions we have in our bags to propose the Plutus team when they have time, if they have time.
Well, when they have time, indeed, yes. In 2023, when they have time to do so.
Okay, well then I have plenty of features to be added 2023.
Okay, well, let's move on to assurance. I mean, I know you're interested in giving users of Glow assurance about how their contracts behave and don't misbehave. Could you tell us something about that?
Yep. So we were recently awarded a Catalyst Fund grant to begin implementing formal verification. And we have already had a lot of ideas about what primitives we want to start proving. And we're beginning the process of getting the build of at least prototyping and thinking about how we're going to more fully start implementing these things. But it's an ongoing process, and it's something that, we're going to start small, and as we go along, we'll be able to add more and more. But we have to get started somewhere.
Well, good. Well, I look forward to hearing the results of that. That's good. You've got Catalyst Fund. I think I will encourage everyone to apply for Catalyst funding. It's been a great source of ideas and concepts and implementation. So that's great.
I would add something to this question. I would like to say that a very important point is that it's very hard to retrofit formal methods on top of an existing language that was not defined for it. If you take, let's take JavaScript and let's try to prove a program in JavaScript, you'll find that most of your proof will have to deal with just the small inconsistencies and the small details of JavaScript that have nothing whatsoever to do with your program domain, and you will spend all your time working on those things. One thing we do with Glow is that we think about formal verification and logic as we add features, and that's a very important requirement for us. When we add a feature, how does it affect the logic? And we have just started implementing the logic in automated way, but even if it's a semi-formal or not implemented on paper way, we want to understand what the programs mean, and that's very important because you can't add that afterward. It's too late afterwards. So
definitely. No, that sounds great. Good. Perfect. Well, let's move on to how would you characterize a typical Glow user, a typical Glow use case? Can you, or is that an impossible question?
No, I mean, I think that the typical Glow use case is really focused most likely around our portability and our ease of use. Those are the two things that really make Glow stand out in the Cardano sphere, you know. And those things are for any sort of DApp that you want to write one time, but have run wherever you want to, wherever it makes sense for your business purpose. You can imagine a world where certain qualities are going to be better for you at certain times that are available on different chains. And Glow gives you the opportunity to do that, but also to not have to put all of your capital outlay that you've put into building this DApp and have something show up that causes you to lose all of it because the chain becomes no longer functional for you. You have some blocker that, like, your business model doesn't allow your gas fees to go up to $50 per transaction, for example, or whatever else. And then again, the other part of that is, like, as we kind of mentioned, you know, Haskell is probably never going to be for everybody. And, like, we're an avenue to give you the same security and the verifications that you can get with Haskell, but using something that is a lot more approachable.
No, that makes perfect sense. Yeah, no, I mean, it's though the number of Haskell programmers has been going up, and I think not least because of the blockchain work that's been going on. I can certainly, you know, and we did a similar thing with Marlowe, that we wanted to embed Marlowe in JavaScript so that people were able to use JavaScript constructs in order to design and describe Marlowe contracts. It's a slightly different relationship than yours with JavaScript, I think. But certainly, yeah, allowing different people different ways in to get writing programs is clearly important.
Sorry, just that, like, I don't mean to disparage Haskell in any way. Like, Haskell is an incredibly powerful language. But it's not something that, like, your cousin Mike, like the guy who your family knows, he can always build a web page for you, you know? Like, cousin Mike is unlikely to be a Haskell dev. And for at least a decent amount of time into the future. And we think there's a large number of people who are interested in the blockchain space and in running a DApp, running something that can operate in blockchain, but would either not know, one, wouldn't know how to use the Haskell, wouldn't be able to use the Haskell, and two, wouldn't necessarily be sure where to find somebody for it either.
Mm-hmm. No, that's a good point.
I would like to add a point, is that we consider that for Glow there are several levels of users. There's an end user. The end user does not program anything. He just wants to use a thing, something that has already been audited by someone else. Like, I want my mom to be a potential end user, and she knows nothing about computer science. That's the end target of the language. We want in the end to build things that have end users who don't understand nothing about computer science. We also see another level would be the integrators. The integrators, they don't have to understand really Glow either. They have to be good at maybe JavaScript or another Glue language like that, and they want to piece the pieces together. They're totally the wrong person to write a software that is like blockchain, like kind of security with like formal methods. Formal methods are not for them, but they want to be able to reuse these existing bits and connect them together and extend our GUI or build their own GUI on top of it. And they want to use Glow in a way, but they don't want to modify any Glow program. They just want to say, here's an existing Glow program. It interfaces to my JavaScript or Python or whatever I'm using, and I'm going to use that. And it will be, the blockchain part will be safe. I still need to get the other part safe, etc. But at least I'm not going to make a blockchain mistake in my app because I introduced something somewhere. So we want to have these integrators. We want to also have the Glow developers. A Glow developer, he takes this language, he builds a slightly modified program or a very modified program, is it? So these guys, you want guys who can deal with some of the complexity of blockchain, but they are not blockchain specialists. They are specialists of, say, auctions or futures or insurance or supply chain, whatever it is. Like, they have a business, they are specialists of the business logic, and they want something that protects them from the blockchain in a way. They want to be able to use a blockchain, but without being a blockchain specialist. So that, and finally you have the level of the implementers. Oh, these guys they want to extend Glow and extend, here's a new blockchain capability I've heard of, I want to make it happen. And so there are different levels of users, and we want to be able to support all of these users. And
that makes perfect sense. Yeah, that's good. I mean, I think Marlo, we'd see similar. Clearly, everyone's going to hope they have lots of end users, but certainly being able to wrap up complex parts of blockchain interaction inside components that are more widely usable, I think is an excellent goal to have. I mean, just in terms of spreading the word about Glow, do you want to say a tiny bit about the developer program and the Mooc before we conclude?
Absolutely. So the Mooc is coming up very shortly. We are open now for applications to people who want to take our massive online course and learn how to use and build Glow programs. The first course of that is going to be the 28th of this month. So we are in the process of ramping up and getting applications in and getting started with that. And as we move forward, we're going to have more and more of a developer program. We'll kind of like keep your ears open. We'll get you more details as we develop along that path and lay out more things. But our intention is to be getting much more active in terms of hackathons and other developer community events to get a community of Glow users started and get people started building and helping each other find new and amazing things to make with our language.
Great. If people want to find out more about the Mooc, where should they look? On your webpage? What should they Google for to get to the sign up?
So the sign up, we are going to have it available both on the glowlang.org website or on our company's website, which is at MUKN.io, moon.io. Perfect.
That's great. Thanks very much. So I think the final thing people will want to know is, when can I run my Glow contract on Cardano? What do we have a date for that?
Probably early next year.
Early next year. Great. Okay, well, thanks very much, guys. It's been really interesting. Had a really good conversation and talked about the things we planned to talk about and a few things we haven't. So that's been great. Thanks very much indeed. And catch up with you soon. Thanks. Bye.